The second big theorem that we want to talk about in first year calculus is called the mean value theorem. It turns out to be especially important because the big secret to calculus, the big reveal that's going to happen somewhere around chapter 5, when it came time to prove how all of calculus is related, the way that we proved it required the use of the mean value theorem. So we don't see that so much as first year calculus students, but no, it's coming. But we do still want to understand this theorem deeply and make sure that we can use it. It's absolutely 100% tested on the AP test every year. So the mean value theorem says that if a function is continuous over an interval a to b, and remember the brackets mean a and b are included in that interval, and the function f is also differentiable on the interval a to b, notice here the parentheses mean that a and b aren't included in that interval, then at some point c, there's some x value c between a and b where this must be true. F prime of c equals f of b minus f of a over b minus a. So just notice what we know. We know what this means. This means the derivative. So there's some place on the function where the derivative, the slope of the tangent line, is equal to, what's this? This is average rate of change, which is the slope of the secant line. It's the same as average slope. So the mean value theorem promises, it guarantees that at some place on the interval a to b, the actual slope of the function equals the average slope. So we're going to talk more about what this means when you see the picture down below. But before we move on to that, so a quick reminder, I'm confident you talked about this in your Algebra 1 class and in your geometry class. This is what's called a conditional statement. The mean value theorem is an if-then statement. So what we want to make 100% certain, this is one of the MPACs, one of the things that you have to be able to do in calculus, is before you ever try to tell me that this statement is true, you have to convince me first that you checked that the ifs, the if parts are true. So we want to understand what that means, and we have some words that we use to describe this. The two things that must be true for the mean value theorem to hold are called the hypotheses. That's true for any conditional statement. This one happens to have two, but the part of the theorem that comes after the if, that's the hypothesis, or in this case, hypotheses. There are two of them. And the thing that comes after the then, after the word then, the thing that happens if those ifs are true, that's called the conclusion. So there are two hypotheses of the mean value theorem. There's a place for you to write these in. The first hypothesis is f of x is continuous over the closed interval, so interval with brackets, a to b. The second hypothesis is f of x is differentiable over the open interval with parentheses, a to b. Those are the two hypotheses. The conclusion is the part of this statement that comes after the word then, and that is specifically, at some point c between a and b, f prime of c equals f of b minus f of a over b minus a. So you want to make sure that you have those two hypotheses and the conclusion written in on that first page of your notes. All right, before I change the slide, I want you to look at the picture at the bottom of that first page. The directions say that you're going to draw in the secant line, that's the line segment AB, and then you're going to draw in the line tangent to f at the place where x equals c. So, number one, drawing the line segment AB, and if you would continue that actually past A and B, it won't be an assignment anymore. You can draw in the line that contains A and B, and then draw in the, this is what we practiced a little bit before the break started, the place on the graph where the tangent line, imagine running your pencil along that function until you found a tangent that was parallel to the secant you drew. Okay, so if you did that, I'm assuming you got a picture that looks like this. This is just a picture way to think of what the mean value theorem promises us. If you have some function f that is continuous and differentiable, so no holes, no skips, no points or cusps or corners or anything pointy, no vertical tangents. If you have a function like that, so here's a very nice, plain, boring, smooth f function, and you pick 2 points on that function, here they happen to be called a and b, capital A and B. You could think about the ordered pair. This is b comma f of b. This point here, capital A, has the ordered pair a comma f of a. There, the mean value theorem guarantees that someplace in between a and b, they just give it a name c, but it has to happen between a and b, somewhere on that same interval where you're investigating. There's going to be a tangent line, a place where the derivative is, or a place where the tangent line is parallel to that secant line, meaning a place where the derivative is equal to the average rate of change, f of b minus f of a over b minus a. So what we're saying is that there's a place where the slope of the tangent is equal to the slope of the chord, the secant a to b. Now your book has a lot of questions about, a lot of questions where you practice figuring out what that c value is. So they'll give you a function and an a and a b, and they'll ask you to figure out what c has to be so that f prime of c equals f of b minus f of a over b minus a. It's a good exercise. I think I asked you one question. You want to be able to do that, but they're very, very rarely going to ask that on the AP test. The way that the mean value theorem is tested on the AP test, it's quite a bit different from how the topic is presented in your textbook. So we're going to do these next 2 examples. I want you to make sure that you copy down the language I use and come to class with lots of questions, because we don't have examples in your textbook. This is a topic that's just not easy to cover in a textbook. So make sure you do these next 2 practice problems.